Hello everyone. Welcome to this training session on statistical analysis using Excel. As a part of this session, we will look at the various aspects in which the two variables can be presented, two variables taken together. Till now, whether we have done the graphs relating to pie chart, bar chart, or histograms, frequency, polygon, all these things, or even the calculations like descriptive statistics, mean, median, or standard deviations, any of the calculations or any of the graphs which we have done till now, the major thing was we looked at single variable at a time. But now we will see, if I take two different variables at a time, what are the various models of representation as well as graphing, creating graphs for taking two variables together in order to understand the relationship between the variables. So we will look at a few major aspects as a part of this chapter. Let's look at our data itself. We will talk about the instances like, let me call this as two variables at a time. So some of the things which we would be covering in this aspect are, one being the contingency tables or contingent or contingency tables. We'll look at that aspect, and we'll also focus on side by side charts, these two are very common kind of applications for nominal or ordinal data, and we would also like to look at the scatter plots, which would be more and more appropriate for continuous kind of a data. So these are the three major elements we'll focus on, and in case we come across anything more as a part of our session, we can typically add that up. Now, what is a contingent table? It's nothing but it's a summarization or a frequency kind of a table itself, but having one variable in the rows and having another variable in the columns. So, for example, on this data, if I want to summarize the smoking status across the various genders, which means I am looking at two variables together, or probably I would like to see the education levels across the various marital statuses. When I look at something like this, we talk about the contingency tables. And the most important Excel feature that comes up as a part of the contingency tables is the pivot table again. But remember here, the most common scenario when we will apply the contingency tables is, we have both the variables which we are taking together either as nominal or ordinal, both of them being the categorical variables. If even one variable is a scale variable, it is not advisable to use a contingency kind of a table. Now, how do I prepare it? The better strategy being, you go for a pivot table. So I'll say insert pivot table. All right, I'm doing an insert of the pivot table where my data is still the same. Right from this L column to A column, I would be selecting my data. whereas the place where I would be pasting my analysis is here. All right. Okay, I think my data need to be saved. Just give me a minute. Okay, let me try it now. Pivot table, I am inserting a pivot. The table range is this entire area, my A column to L column, and if I am going with a pivot, alright. Now here I want to take two variables at a time, because what is our question? I want to look at a summarization between the smoking status across the various genders. So let me take gender on either the row or a column. So let me take the gender on the row. Alright. So it is presenting me the genders that are available in the data. There are males, there are females, and probably there are blanks. So better that I remove the blanks. So it shows me only male and female as the genders. And probably the same thing I can talk about smoking status or education level. So let's say I am dragging the smoking status here. So let me define the question. That would be much better for us to do the analysis. So I'll insert one new row and actually define a question. What is the question for us? Summarize the frequencies of smokers across the genders using contingency table. So once I select it, I get something like this. The rows contain the gender, male and female. The columns contain the smoking statuses. Now I need the number of people who are falling into each of these categories. So any of the variable, let's say the ID variable itself, if I want, I can drag it onto the values. So this kind of a table, what is this telling? There are 25 females who do not smoke, whereas there are 22 males who do not smoke. And similarly, there are 7 females who are heavy smokers, whereas there are 9 males who are very heavy smokers. Something like that. So it creates a simplicity for us in terms of summarization of the data. If you see here, it has summarized the data in a row as well as column kind of a scenario, and these are what we call as contingency tables. Alright, probably let's try out one more example. Summarize the frequencies of education levels across different marital statuses. I don't know how many marital statuses are there in the data, but without that also we can very well use our pivot to actually extract what we really require. Again, the data goes to be the same. Alright. On this data, I'm coming up with education levels and marital status. So probably let me take the marital status in the row labels. So I'm dragging the more marital status onto the row labels. Here you are able to see the diverse, married, single and widowed being in the row labels. But I don't want the blank to be displayed here, so I can go here and remove the blank. So only the 4 existing marital statuses are shown here. Similarly, I want the education levels across the column. So I'll go and select the education levels and put it in the column labels, which will again show the 4 different education statuses across. And now I want the count or the frequencies who are falling into each of these combinations. So that is where probably I can drag the ID of the person into the value label. So how is it coming out? People who are graduates, 5 of them are divorced, 24 are married, 7 are single. Something like that is the numbers that are coming out. Similarly, from the illiterate category, 2 of them are divorced, 7 of them are married, 4 are widowed. These kind of calculations are coming out across. Right? So this is one of the ways in which we can summarize a two variable together kind of scenarios, and probably the presentation of this can happen even through a pivot chart also. Just like the way we have used a pivot chart in a in a one single variable kind of a scenario, we can use the pivot chart even in a 2 variable kind of a scenario also. All you need to do is click on your pivot table, go to the options and click on the pivot chart, probably a column chart itself. We get a better display of the pivot chart directly. Across the various marital statuses, the plot for the different education levels is coming out by the system, is displayed. So we can directly reuse the chart, and we can play around by playing around here. Let's say I don't want the postgraduate data to be displayed. I can remove the postgraduate data from the list and even the blank from the list. Automatically, even my chart is also updated accordingly. Here, if you see in the chart, the postgraduate data is not present. So your pivot table and pivot chart are very much linked, especially when you are doing it through this, especially for a contingency table kind of a scenario. Now, as far as this contingency table is concerned, people also express not just in terms of numbers, but they can also be expressed in the form of percentages. Not just in the form of numbers, they can also be expressed in the form of percentages, and the percentages also can be of 2-3 different types. So there can be mechanisms of row percentages separately, or even column percentages separately, or even a percentage of the total. So all these 3 kinds of mechanisms can exist as a part of the analysis. Now, what do we mean by the row percentage or even the column percentage? The same logic, right? You select your pivot table, go to the pivot table options, and or in the values here at the bottom, in the value field settings, you select the show value as, instead of normal, you select it as percentage of rows. When I select it as percentage of rows, everything gets updated in the row percentage. Out of the total females, 100% of the females, 50% of them do not smoke, 14% are heavy smokers, and 36% are occasional smokers. The same logic you can take it into any of your data as long as it is a 2 by 2 data, 2 variable kind of a data. If you express that in the form of percentage of rows, you will get this kind of a display. The same logic, if I want to express it as a percentage of the columns, all I can do again is, let's say I will do that on the marital status vis-a-vis the education categories. So I can do the same count of ID, value field settings, show value as, instead of normal I would be selecting percentage of column. That's it. So here you will see every column it is shown as some percentage, and the good thing is the graph is also upgraded accordingly. That's the benefit that we can derive in the process, and the grand totals for all the columns are 100%. So it means that probably there are 66.67% of the graduates are married, whereas 53.85% of the illiterates are married. So we can very well draw different conclusions by looking at the percentage of the row totals as well as the percentage of the column totals. Now similarly, people can also talk about the total percentage totals also, percentage of the total, which is nothing but, in the same example, if I have to use the percentage of total, all I can do is again value field setting, show value as, instead of percentage of column, I'll go for percentage of total. These are the three major things as a part of the pivot table that we can use, which will also tell me that 39.13% of the total graduates, there are 39.13% of total graduates. Similarly, 14.13% of the data are illiterates, and 46.74% of them are literate. So this kind of summarization also can be done, or probably the other way, 52.17% of the total people in our data set are married, 9.78% of them are widowed. That kind of summarization also can very well be drawn from the contingency tables. So a contingency table along with a pivot chart. This pivot charts, especially when I am doing it as a column chart, I can also call it as a side-by-side chart. Right? A pivot table which can be taken into a pivot chart, and that pivot chart, especially as a column chart, if I am plotting, I will also call it as side-by-side chart. So either I can represent the two variables at a time in a tabular kind of a format, like the pivot tables, which are technically called as contingency tables, or I can present it in a chart kind of a form where I use a pivot chart, or technically it is being called as a side-by-side kind of a chart. Again, the values can be represented either in a number form or even in a percentage kind of form. Individually, they can also be in a percentage of rows alone, or percentage of columns alone, or the percentage of totals also. Now, what if this entire thing is applicable if my data is more of categorical? The two variables which I am considering are more of categorical in nature, either both of them being nominal or ordinal, or one of them being a nominal and one of them being a ordinal. So both the variables, as long as they are categorical in nature, we can very well use the contingency table as well as the side by side kind of charts. Now what if the two variables I am looking at, or what if the two variables I am working with are scale kind of a variables? Like for example, I would like to create a question here. Find the relationship between the cholesterol levels and the blood pressure levels. Generic relationship between the two scale variables of data. For whatever the set of people whom we have observed, we want to find out the relationship existing between the cholesterol levels and the blood pressure levels. For this kind of a scenario, we talk about the plot which is called as a scatter plot. Right? There is a graphical way of presenting that kind of a relationship, and also there is a calculated value to express that relationship. The graphical way is what we are calling as a scatter plot, and the way I do that scatter plot is straightforward. Insert scatter plot. In the charts I can go for a scatter. So select the scatter chart, and probably I can select the data. Here it asks me what is the source of the data. Rather than that, I can go here. The series name, I can call it as blood pressure versus cholesterol. Blood pressure versus cholesterol. I'll take one of them on the x-axis and the other one on the y-axis. So let me take the blood pressure values on the x-axis. Okay, I'm taking the blood pressure values on the x-axis and probably the cholesterol values on the y-axis. Okay, now let's look at the way the chart is coming out. Alright, this is the way the chart has come out, but yes, because we don't have some of the values, the better thing being you again do a select data. Get into the edit chart, because we have some blanks in the data. The problem is coming out with respect to that. So what we can do is the blood pressure on the x-axis, we can select only from here to the down. The same logic we can apply to the cholesterol levels. We can very well select the cholesterol from here to the last. In fact, in one of the records, it looks as if the cholesterol is being identified as 0. Why is that? No. Is there a 0 in our data? No. Alright. Yeah. Now, the better point is, let's not keep these points joined together. So that's where what we can do is we can again select the data or change the chart type. Instead of having the connected kind of chart, we can go only with the markers. So only with the markers, probably there is something that is showing that as the blood pressure is increasing, the cholesterol levels are also increasing and vice versa. To find out what is the kind of relationship that is existing between the two, to look out for the graph in a much better manner, what we can also do is we can go for what is called as a trend line as a line depicting the relationship between the two variables. For that, what you can very well do is you select the chart, under the layout tab, go for a trend line and go for a linear trend line kind of an option, which you can get from more trend line options. From this more trend line options, you can very well choose the linear trend line, and if possible you can also display the equation in the chart. We'll talk about this slightly later, but for the time being we can also talk about displaying the equation in the chart and also display the R squared value on the chart. Okay, there is an equation that is displayed, and what you are seeing is the graph, the line that has been drawn. There is some level of upward movement in the line. It's not a fully flat line. There is some level of upward movement in the line, which says that the relationship between the blood pressure and cholesterol is a positive relationship. As the blood pressure levels are increasing, the cholesterol levels also could increase and vice versa. But what we are also seeing from this table is the R squared, which is 0.138. We will see slightly a while from now that if the relationship between the two variables need to be very strong, the R squared should be very close to 1, not very close to 0. The R squared, which is a measure of the strength of the relationship between the two scale variables, can be obtained through a formula called correlation. R is correlation. The square of the correlation is actually called as the coefficient of determination. So let me use two words here. The correlation, which is nothing but R, which can be found out in Excel through a formula called correlation. Correlation between the array 1 and array 2. Array 1 for me is cholesterol, comma array 2 is the blood pressure. Between these two, if I find out the correlation, it is coming out to 0.37, and R squared, which is nothing but the square of the correlation coefficient, which is nothing but this value squared, is coming out to 0.13, which is what is being displayed even in the chart here also. Either I can use the formula, the correlation, and then compute the R squared, or even I have a formula directly called RSQ. RSQ is also known as R squared. Again, here also I am talking about the two variables y and x. So these are my y and x respectively, which will tell me, even in this case, I am getting more or less the same value. Either I use the R squared kind of a formula, RSQ, or I can find out the correlation first and then do the square of it, or I can go for a scatter plot and then put a trend line into the scatter plot. All these things will give me the relationship between the two scale variables altogether. Now probably just for a practice, let's try out find the relationship between the IQ levels, IQ scores, and what else do we have as the variables? Find the relationship between the IQ levels and the blood pressure. As the IQ levels are higher, is there any kind of a relationship with IQ and blood pressure from the data which we have observed? The same logic, I'll go for insert, scatter plot, right? Or the other way to do that is directly select the two variables of data. So the blood pressure and the IQ levels, I'll select both of them, go for a scatter plot, this kind of a scatter plot. So directly I am getting this kind of a plot. I can copy, cut, take it to my analysis sheet, wherever I want my data to be, my graph to be presented, right? So this is the chart between the IQ levels and blood pressure levels. If at all I want to find out the trend line or the relationship between the two, I can go for a trend line, more trend line options, linear trend line, the trend line, more trend line options, linear trend line, then I can very well choose the display equation and display the R squared. Here we are seeing that the R squared is again very close to 0, 0.02. Look at the correlation R. In this case, the correlation R is very less. Correlation between the two variables which we are considering being the blood pressure, comma, the IQ levels. So the correlation is almost minus 0.14. So it shows a negative, but it is very small. So if I am looking at the R squared for it, which is nothing but, I will take the correlation value and do a squaring of it, which gives me 0.02, and that is what we got from the graph also. So from this we can very well say that because the R squared is very close to 0, we can very well say that the relationship between the IQ levels and the blood pressure levels is not anything significant. There is no straightforward linear relationship that is existing between the IQ levels and the blood pressure levels, which can be identified both from the scatter plot as well as the formulas like correlation and R squared. So whenever we have two data to work out with, if both of them are nominal or ordinal, which means both of them are categorical in nature, we can establish the relationship between them using the contingency tables as well as the side by side charts kind of stuff. But if I have to establish the relationship between the two scale variables, the most important solution that I can resort to is the scatter plots, and to find out the depth of the relationship between the two variables, the strength of the relationship between the two variables, I can very well resort to the plotting of the scatter, the computation of the correlation and R squared. So as we move along, we would be seeing that if at all the relationship between the two variables is stronger, probably I would be using one variable as an input to predict the other. So that is where we bring in the concepts like regression and all at a slightly later point in time. But for the time being, my intention should be to do a scatter plot, and from there look at the linear trend line, which is the best fitting line which joins all the points. So the better it can join all the points, the stronger the relationship between the variables is. Otherwise, you will definitely find a weaker relation between the variables, as we are observing in this kind of an example. Right? So any two scale variables you are taking together, if you want to find the relationship between them, you should resort to a correlation and a regression kind of an analysis. And in case you are looking for two categorical kind of a variables, it's better that you summarize them using contingency tables as well as the side by side charts. All right. So in this session, our focus is to give you the orientation regarding those kind of charts. If you have any further queries regarding these charts, you can very well feel free to give me a call on the number that I have mentioned below, 98480-12123. You can even send in an email to me at the email address vamsidhar@pacegurus.com if you have any of your doubts, and I can get back to you with a detailed explanation on that. Thanks a lot for listening to this session. Thank you very much.